Hi everybody, so today we're going to be talking about ventricular septal defect. And what ventricular septal defect is when there's a hole in the wall between the two ventricles in the heart, which is called the ventricular septum. So let's take a look, and if we look, I'm going to draw a picture of a heart here, and then over here we have what we call our right atrium. And just really quick, remember, it says right atrium because it's on my right side. Just like my right arm is on my right side, even though if you're looking at me, it's to your left. So this is the right atrium. This is the left atrium. Okay, this is the right ventricle. And this here would be my left ventricle. So basically, right here, this right here would be my interventricular septum. So there's my interventricular septum. And as you can see, this is a wall between the two ventricles. What's going to happen in ventricular septal defect is we will have a hole in here, and then blood can flow back and forth. So let's take a look at this real fast. And basically the way that blood usually flows in the heart is you get deoxygenated blood. This is blood without oxygen, so you get deoxygenated blood from the body. And this is coming from the body. It's going to come into the right atrium. Then from the right atrium, it's going to come down into the right ventricle. Now, from the right ventricle, we have an artery right here called the pulmonary artery, and the blood's going to go out through the pulmonary artery up and to the lungs, where it's going to get oxygen. So now that blood is going to come back from the lungs, right? And it's going to come into my left atrium. But if you notice now, this is oxygenated blood. So oxygenated blood, I'm writing in red. Deoxygenated blood, I'm writing in blue. So this is going to come now into the left ventricle. And from the left ventricle, what normally happens is this passes out through the aorta, and then it's going to go out to the body. Okay, so it's going to come like this, and then it goes out to the body, and we have some arteries that come off the top here. That's not for this video. But anyways, so it goes out to the body. Now, here's what's going to happen in ventricular septal defect. So, well, once again, just to reiterate, so I'm going to get blood going through here out to the body, right, to the body. So let's take a look at ventricular septal defect. And now, this is what's going to happen. When the body's being formed, this is going to happen somewhere around the 26th day of formation after the sperm has met the egg. Right? And basically, I'm going to start forming my atrial septum, and I'm going to start forming the valves. In the center right here, we have something that is called the endocardial cushion. And the endocardial cushion just helps in the formation of the heart. Now, coming off the endocardial cushion, what's going to happen is I am going to have a membrane that starts to grow down this way. All right, and we call this the membranous region. Okay, so the membranous region is going to grow downward. Okay, and then we have something called the muscular ridge, which is going to grow upward. So this is my muscular ridge. Okay, and once again, so my membranous region is growing down, my muscular ridge is growing up, and they should meet in the middle and form that ventricular septum, the interventricular septum. If you notice right here, we have an opening. So what's going to happen in ventricular septal defect is this opening does not close. Ventricular septal defect. Okay, so that has not closed now. All right, so that's not closed yet. So now, here's what's going to happen. I'm going to erase this stuff real quick now. So here's what's going to happen now is now I get blood that comes in from the body into my right atrium, just like always, right? Coming in from the body, just like it always does. However, it comes down into the right ventricle. Now, here's the thing that's going to happen. Is because this part of the heart has to pump blood out to the whole body, usually this has higher pressure on the left side than on the right side. So this is usually higher pressure on the left than on the right. So this is going to have lower pressure. Okay? So what's going to happen now is, for the most part, you would think that blood would go this way, but it doesn't, because of the fact that we have more pressure. So this blood here just ends up going out to, it goes into the pulmonary artery, and now it's going to go out to the lungs, just like it always does. So now if we look, our blood's going to come back in from the lungs, just like it always does, and now it has oxygen. It's going to go down into the left ventricle, just like it always does, right? But now, when the heart beats, when this heart beats, some blood is going to go up into the aorta, right? Just like we said a minute ago. It's going to go into the aorta. But some blood is going to go over into the right ventricle. Okay, so it's going to go over into the right ventricle. Okay, so now, here's the thing. So once again, it can go into the aorta, or it can go into the right ventricle. So now, here's the thing. This blood is oxygenated. If this was closed, that oxygenated blood would never come over here. So this side's not used to having oxygenated blood. So because it's getting oxygenated blood, what's going to happen is we're going to have an increase in oxygen saturation. Oxygen saturation is just the amount of oxygen that's in the blood in the right ventricle and in the pulmonary artery. Right? Which would make sense because you have this blood that's coming over this way. Right? So, for the most part though, if I have blood that already has oxygen, it's taken a second lap to the lungs, that's really not a big problem because we need the oxygen, so it's got the oxygen in it. It only becomes a problem if I don't get enough oxygen or enough blood going out to the body. Here's what can happen though, is as we continue, as this blood comes over here, right, and I'm getting blood coming down this way, again, if this was closed off, the blood would all stay here and then go out to the body. But because this is open, I have blood going this way, plus the blood coming this way, the right ventricle has to pump that extra blood out. So we're going to get an increase, there's an increase in blood volume in the right ventricle. Now, because there's an increase in blood volume in the right ventricle, and this has to pump that extra blood out, what we end up with is pulmonary hypertension. All right, so I get pulmonary hypertension. So now, because I got pulmonary hypertension, what happens is instead of having lower pressure, now this side gets higher pressure than the other side. So now this side is lower pressure. Okay? And so what's going to happen now is instead of the blood pumping this way, like we saw when this had the higher pressure, instead of the oxygenated blood pumping that way, what's going to happen now is I am going to get deoxygenated blood going this way. Now, when we get the deoxygenated blood, or the blood going from the right, trying to make this even here, and I'm not having much success. When I'm getting deoxygenated blood, or I'm getting blood going from the right ventricle into the left ventricle, that's called Eisenmager Syndrome. So let me erase this real quick, right here. And this is going to be called Eisenmager Syndrome. okay? Because now I'm getting the blood going the opposite way. So now, and then once again, the problem I'm going to have now is this blood is going to be going out to the body and it's not oxygenated. So because that blood can go out to the body and it's not oxygenated, I can end up with cyanosis. Okay, we can end up with cyanosis. And what happens in cyanosis now is people can get something like blue lips or bluish fingertips. Because there's not enough oxygen. Okay? So, not only that, but I can also get a murmur in here. It's called a holocystolic murmur, because of the fact that the blood's shunting through there. I can actually get it going either way. So here's some of the problems that I can have with this is there can be shortness of breath, right? Because if you think about it, if I think about this, this doesn't have enough oxygen. So what the body does is it registers in the brain that, hey, we need to have more oxygen. You need to increase your breathing, right? So if I have shortness of breath, what's going to happen is I'm going to get an increase in breathing rate. Okay, I might get an increase in breathing rate with this, which we call tachypnea. Okay. I can also get an increase in heart rate. Okay, and with the increase in heart rate, we call that tachycardia. Okay, so that can occur also. The other thing you may have is no symptoms. So there may be no symptoms. Okay, and then the last thing, there's other symptoms that can happen, but the last thing I'm going to cover is if this is bad, surgery may be required to close this up. So what they would do now is they would go in and basically close this up. And then everything would start to work properly. Okay, so that's it for ventricular septal defect, and thank you for watching.